My name is Pedro Acuña. I'm a PhD candidate at the Biobase Europe pilot plant together with the Ghent University.
And my name is Marta Ferrer, and I'm an R&D engineer here in Biobase.
Here at the Biobase Europe pilot plant, we are an open access facility for the piloting of different bioprocesses, meaning that any company, no matter the size, can come to us with a pilot process at lab scale, for example, and we can do the scaling up of that process to 15 cube, 75 cube. And also what we do is that companies with just an idea, even a process at lab scale, can come to us, and we can also do the whole lab process development and then scale it up.
That's actually produce bioplastics with microorganisms. Those microorganisms that are used in the industry to produce, for example, beer, those are the same that we use here to produce bioplastics. And with the extra added value that we use CO2 as a starting point. This CO2 that can come from, for example, those industrial companies and the off-gas emissions that they have, we can produce bioplastic from them. And here in Biobase Europe pilot plant, we do the lab scale development of some of the technologies, and we upscale them to higher volumes.
Here at the Biobase Europe pilot plant for the COSMOS project, we are developing a whole value chain going from CO2 to bioplastics via a two-stage fermentation process. In the first stage, we have a gas fermentation process that aims for the conversion of CO2 into an intermediate compound called acetate, whereas the second stage have a liquid fermentation process that aims to convert the acetate into bioplastics. So for the COSMOS project and related to this first stage, we are scaling up the hydrogen plus CO2 conversion into acetate to 150 liter scale within the Biobase mobile pilot plant, which is a gas fermentation container that we can move to different industrial sites for the conversion of real industrial gases. For other EU projects, it has been already utilized to convert steel mill off-gas into bioplastics and biomass gasification syngas into acetate. So moving on to the second stage.
This is a liquid fermentation, and in this liquid fermentation we have a two-stage. We have a growth phase where the microorganism grows as much as possible, and a second stage where we want to produce our bioplastics. And this is done via monitoring the nutrients. So in this first stage, we provide all the nutrients that they need in surplus conditions, and at a certain point we induce a limitation of one of the nutrients, and in this case the microorganisms can no longer divide, but they still keep on consuming this carbon source, this acetate, and they accumulate it as energy reserves, and those energy reserves are our actual bioplastics.
So basically that's the whole value chain of going from CO2 to bioplastics within the COSMOS project.
This